Assalamualaikum warahmatullahi wabarakatuh. So we are from Group F1. We are going to present our lab report PE2. My name is NABILAH binti AHAMAD.
My name is AZHARI bin AZMI.
And my name is akmal bin RASMAN.
Okay, so for the first experiment, this is current and voltage wastage of the converter for different delay angles with resistive load. So at first we adjust the one after another the delay angle, which is 0, 30, 60, 90, and 120 and 180 degree. So we capture the corresponding rectifier waveform. This rate is voltage BRN and control voltage is thyristor BPL, output DC voltage VDC, and the input rate is current IR together with the output DC current. So this is the circuit, and then this is the waveform that we get for 0 degree, the 30 degree, 60 degree, and the 90 degree. Next is the 120 degree, and the last one is 300 degree. So from the waveform, as the delay angle increase, the waveform from VDC goes from continuous and to discontinuous until it becomes a straight line, and its voltage level decreases until about 0 volt, as shown by the graph in figure 2 to 7. As the delay inverse increase, the waveform for IDC went from continuous to discontinuous before settling into a straight line at 0 ampere. So meanwhile, the IR waveform transited from a quasi-sinus to a pure sinus wave, like this. Okay, so the next one.
Okay, for experiment 2, we need to find the determination of the control characteristic. B to indicate the theoretical and the usable control rate. So at C, we need to indicate the range of the intermittent flow. So we adjust the firing angle at 0 and need to measure the output voltage VDC. So we get the VDC at 1.05257 exponent 5002. So we need to adjust the delay angle according to and measure the corresponding output voltage. So the respondent is on the table 1. So this is the value voltage and power for the different angle for 0, 10, 30, 90, 120, 150, and 180. So this is the plot graph for the control characteristic VDC over VDC alpha with respect of firing angle. So it decreases. Next, show the figure for the theory graph. So it's a proof that both decrease, same as theory. So based on the result simulation above, indicate the usable control range of delay angle and compare the theoretical range. So the usable and theoretical is the same. So 5, they indicate the range of intermittent flow of delay angle. So the range is between 60 and 90 degree.
Okay. For the experiment 3, input line current, resistor or resistive load. Okay, with the delay angle alpha to equal to 0. So this is a output waveform for the angle equal to 0. And then next, we obtain the harmonic content of the red phase input current by performing a FFT analysis. So this is the output harmonic waveform of FFT at the red phase input current. And after that, in experiment 3, the previous circuit which is in figure 7 is used with delay angle alpha equal to 0. Then the output waveform for the current red, current yellow, and color blue, and red phase voltage VRN were captured in figure 16. In this experiment, input line current wave shape and rate phase voltage were observed using six-pulse daily fully controlled bridge rectifier with resistive load. In figure 16, rate phase voltage waveform is used to achieve sinusoidal waveform which is continuous at the positive cycle and then negative cycle. Since this rectifier have a single switch and perform input wave shaping naturally without a need for a complex control circuitry, they are suitable for low-cost three-phase AC/DC conversion. So in figure 17, the output harmonic waveform were captured by performing fast Fourier transform analysis at the rate phase input current only. From figure 17, at the first peak of harmonic, which is the rate phase input current is 50 Hz, is 0.77 ampere. Generally, the first harmonic has a 50 Hz frequency and the second harmonic has twice frequency, which is 100 Hz, and the third harmonic has triple frequency which is 150 Hz. As the result, when the frequency increases, the value of phase input current will decrease. So the harmonic distortion at the input current will reduce without increasing the output voltage beyond the vertical level. That's all. So next, this is to identify the thyristor based on the circuit below. So the G1 and G4 is for the blue wave, and the G3 and G6 is for the green wave, while the G5 and G2 is for red wave. Okay, that's all.
So for the conclusion, this AZMI 6 pulse, which is full wave, is fully controlled three-phase bridge, which resistive load was conducted to observe and analyze current and voltage shape of a converter for different delay angle. So it is including shape of the input line current. So it also covers on how to determine the control characteristic of the converter that show by theoretically and usable control range as well as the range of the intermittent flow. So from the result obtained, the value of theoretical has been approved by calculation has almost same value as the simulation. So the 6 pulse controls the three-phase bridge rectifier with resistive load which has significantly lower output voltage when the firing angle is increased. In 6 pulse fully control, which is full wave, all the thyristors are control switch turn on when at interval 30 degree as the suitable trigger signals. So this type of converter is extensively used in industrial power application where two quadrant operation are required. That's it.